in my other monitor. Okay, so for people who missed the intro at the beginning, yeah, my name is Sam. I'm the co-founder and CTO at Oso. We're 8 people currently, almost 9, based primarily in New York, but that line is getting way blurrier these days. As a company, our entire mission is around making security more accessible for developers. And to that end, we've been working on this open source library, also called Oso, which is around authorization. So here's a summary of what we're going to be doing today. So I'm covering a few different topics in this around GraphQL and authorization and that kind of thing. So I'll show you a little bit about what GraphQL is. I'm not going to assume that anyone has even heard of it, if let alone know much about it. It's kind of a cool little technology. I'll talk about where authorization then fits into a web application, and a web application that would be using something like GraphQL. And where it also fits into that picture of authorization, and basically, the main part of this is I have some little demos of an app with GraphQL, and I'll kind of talk through all the pieces of that. So GraphQL, here is a screenshot from their website. As the QL maybe suggests, it's a query language. So you can very much think about this in the similar kind of mind as SQL. But whereas you may be familiar with SQL as being a language you use to query a database, GraphQL, the language is more for a client and a server setup. So GraphQL, for example, has got very popular these days for single page apps, like web front ends to talk to a backend API, right? So the idea of the language similar to SQL, but the use case is kind of more like REST endpoints, like an API. And so as a query language, it has a few things. So there is the schema definition. So like in SQL, you define your tables. You describe the shape of your data. So that's this bit on the left here. So you might have define the project type, and a project has a name, things like that. In the middle, you have the kind of, this is the query language itself, used for querying. And I'll show some examples of that in a second. But this, for example, is, this syntax here would be saying, find me projects whose name is GraphQL. Make it bigger. Will do. Apparently zooming in does not make anything bigger. So why don't I just go to a different screen where I can zoom? How about this? Yeah, let's make this nice and big. I'm going to show this one. Okay. So GitHub actually has a GraphQL API. So hopefully everyone's familiar with GitHub. Place to store and manage your code basically. So I'll start with a kind of a simple example. So this here is a little interactive query interface for GraphQL. So I can interact. I'm logged in as my user on GitHub, and I can interact with the GitHub's API data through this interface. So here I can write a query, and I can ask for things like a simple one. It can actually show the viewer here is the logged in user. So I can see right now that the viewer, here's my login, here's my GitHub username. But I can ask for all kinds of things, right? So I can look up organizations, and you see I'm getting all kinds of nice hints, and I'm kind of using autocomplete here. So I want to find organizations whose name is OSOHQ. So that's our GitHub organization. And I can choose what fields I want to return. This is kind of the core piece of the GraphQL language, is this ability to ask for the exact data you want. So in SQL, you might say select blah, blah, select a column. Here you're choosing the data you want. And this is kind of, this is really interesting because from a web browser talking to a backend perspective, this is a very, very powerful idea that you can ask just for the data you want, and that's all you get back. You don't have to kind of encode it in the URL or do kind of interesting things with that. So here I'm getting the OSO organization. I can, for example, additionally get let's say the first 10 repositories, each nodes. It's all graph based, so you'll see lots of nodes and edges and things like that. But I'm basically, I'm building up this query of all the things I want to get back. I'm getting forbidden, interestingly. Oh, okay, my organization doesn't allow me to list our repositories. Go us. So what about if instead I look for the user called samscott89? Can I list all repositories I've contributed to? And similarly, I'm going to get the names of all repositories I've contributed to, I think in kind of recently. I need to paginate this. So you can see there's kind of a few things going on. I'm getting these error messages, right? So when I look up repositories, it's expecting these various parameters. So I'm going to ask for the first 10. And you can kind of see some of the repositories I've contributed to recently. And right, the idea is I can like expand this out and you know, selectively choose all the things I want to get. And this is all backed by a data schema, so I can pop this out at the right here and kind of go and explore like what is a user type. A user type has a login, and I can see all the various fields I can get. So that's kind of GraphQL. And here's a diagram from the documentation around like where they fit into the application stack. So at the top here you have maybe the endpoints that are exposed to users, to clients, to whatever it is. So maybe you have your RESTful endpoints, right? So like in the URL, like / so and so, much like maybe you can see at the top of the screen. So GraphQL would be like maybe an alternative API that someone could talk to and interact. You have this blue box in the middle, the business logic layer, right? So this is effectively your web app. And they explicitly talk about this like separation as being, authorization is something that should be part of the business logic layer. So if you need to decide what field someone can see, or I got the error earlier that said, my organization doesn't allow you to list repositories, things like that. That should all be implemented at that somewhere else, not in GraphQL. It's not GraphQL's problem. Do it elsewhere. And there's actually there's a very good reason for that. And this diagram I think shows nicely why. It's because you have these various different endpoints. If you try to express your authorization in GraphQL, you're gonna have to do the same thing in REST. You have to do the same thing if you have RPCs and so on. Finally, at the bottom we have our persistence layer, our SQL databases or whatever. Okay, so in this talk, and we're talking about 3 different technologies for some of these pieces. So for the GraphQL piece, we're going to be looking at the Python library called Graphene. So this is a project that gives you this GraphQL. I should say actually, similar to SQL, you often have GraphQL, clients, and you have GraphQL servers, and the only thing they have in common is speaking GraphQL. So like a GraphQL server implementation can kind of do different things. So we're going to use the Python Graphene library to do the GraphQL piece there. We'll do also for the authorization, and we're going to use the Python library Sql Alchemy for effectively implementing our business logic layer. So that's going to be the piece that defines like our data types and responsible for fetching them from the database as well. Okay, and I kind of said this at the beginning of the meetup, but as a reminder, like happy for this to be as interactive as possible. If people want to jump in with questions, ask me to explain through another piece, I'm happy to do that, because I'm going to be sort of walking through some of these libraries and going through some code, so feel free just to jump in and ask what's going on.
I'll jump in before you continue.
Yeah.
So the GraphQL that you used, is it like it sits on top of a database? It sits on top of a REST API? What does it usually sits on top of? Like, what does it query really?
That is effectively left to you to decide. So for example, in the case of Graphene, it gives you it basically gives you a mechanism to expose a GraphQL API to define your GraphQL schema and expose that. So the endpoint. The GraphQL has this idea of resolvers, which is where you effectively implement how data is actually fetched and retrieved, and that's kind of left to you. So you can hook up a resolver to a database, and then GraphQL kind of becomes this like layer between. You can write your own custom resolvers to return any kind of data you want.
So it is something that you control to access something you want to see as a graph, basically, correct?
Pretty much, yeah. It's giving you this query interface to your data that you manage and you organize however you want. So, or rather for the GitHub one. So this, inside this language, I don't need to know or understand how GitHub has actually organized their data behind the surface. Whether this is in a relational database, it could be stored in a CSV file for all I care. The point is they give me this query language so that I can query that data in a structured way. And this is all I need to know about. It is on them to manage, how these fields are returned. So you might imagine this repository's contributed to fields, that might exist in a database. It might just be a custom query that they write on the back end, which, does a SQL query to look for all contributions I made in the last 10 days or something and returns them. That's kind of like not for me to need to understand. All I need to understand is that I have this interface. I can look up a user, and a user has a bunch of fields, one of which includes repositories contributed to, and I can query it. How it's implemented, someone else's problem, and it's not GraphQL's problem. It's like that's where this diagram is talking about the business logic layer. So repositories contributed to is business logic. It's how the GitHub app works. And so like in the case where we're using Graphene and Sql Alchemy, so Sql Alchemy is a kind of a SQL toolkit and also has sort of an ORM component, so you can define Python objects to access the data. That process becomes very, very streamlined. It goes very quickly from GraphQL to SQL. It's like kind of as squashed as you can kind of make it. So okay, so I spoke about Graphene briefly. So yeah, SQL Alchemy, I kind of just went through these. These are kind of the main things we're going to be talking about. These two, and then also OSO. But I'll come back to OSO in a second, actually, and give you a little bit more demo of the app that I've got here. Okay, so here I have, let's make this nice and big. Here I have a pretty simple, not incredibly interesting application, Python app, which is managing some expense data. And so in this file here, I've got my SQL models, and I'm defining them using Sql Alchemy, so I've imported Sql Alchemy. And so, for example, I have my expense class. This is my data model that defines expenses, and you can see in the Sql Alchemy style, I'm using like the ORM piece to define the expenses database, like the expenses model. So this will be something stored in a database in a table called expenses, and the columns are defined like in this declarative style as a Python class. So here I'm specifying that expense has an ID column, it's an integer, it's a primary key. This is going to be reflected in the database effectively. And so the idea of SQL Alchemy is you get to define models in this way, and you now basically have like just Python objects to interact with. You can query and filter and do all kinds of things with. So I have expenses. Expenses belong to projects. So I've got a project down here as well. I have users. Users also belong to projects. So things like that. It's a pretty simple kind of relational data model. So this is my like SQL Alchemy, my very, very basic piece of SQL Alchemy using to define data. And here is I'm using the Graphene Sql Alchemy library specifically, which really like knits these two things together. So the kind of general idea of I think this is a good example. So this is kind of like the core Graphene kind of piece here. If we ignore expenses and projects for a sec, I'm defining the query class. So again, it's like I'm defining my GraphQL schema using Python objects. It's all kind of like getting very there's all like a lot of these concepts getting very, very similar here. And on my query object, which is roughly equivalent to when we're looking at writing queries, right? This is where I'm effectively defining this interface of what I can query. So I'm saying there is like an expenses field, a projects field, and like a user that you can query on my GraphQL API. And for example, you can see here I actually have like a custom resolver for how to get the user object. I can do all kinds of things here. I can have a hello world field, which I'm going to say is I think Graphene string. And right, so by doing this, I'm saying you should now be able to query hello world, and that will return a string. But I now need to tell it how do I return that string. This is where I need to implement my like business logic. So I can say you resolve hello world, It takes in some args, which I don't care about, and it's going to return hello world. So here I've done two things. I've defined a field on the query that a field on the schema that someone could query, and the method that like returns the data for it. That's kind of like the core setup. But imagine that you're doing that, but for complex data types with data joins, and maybe you're doing some sort of filtering or processing on them. Whatever your application needs to do, it kind of gets like funneled through these resolves. Let's go ahead and save that and see if this is indeed available. So this is in my local, it's going to be the same interface, but this is in my local GraphQL instance now. I should be able to, let's make sure this is refreshed. Cool. Oh, okay, actually renamed it for me as well. So you see now, again, so these are the fields I defined earlier. This is now available in my schema. GraphQL has a bunch of like introspection things, so it kind of knows what it's looking for. I can now query for hello world, and there's my data that I just got back and processed. And again, like the idea is that I can do multiple things here. I can ask for more than just one field. Apparently, I can't just ask for a user. I need to ask for a user's email address. So I'm currently logged in as alice@foo.com, or at least that's who the application thinks I am. Yeah, so this is kind of the main part of it. There's a few other things we're doing here, which allows us to actually create some expenses as well as just read them. And the magic is just happening down here. So we're creating the schema object, which takes in the query. So the application that's like hosting all of this is a Flask application, and we're using a Flask GraphQL integration here again, which gives me this very convenient add URL rule, which is basically just exposing that GraphQL API endpoint for Flask. And so here we have like the main pieces here. Now this is like this Flask app is effectively just a regular Flask app, so I can add any other routes of interest if I want. I could implement the rest of my application, ignoring the fact that GraphQL is here, and do all kinds of other stuff. But maybe the GraphQL is just how I expose data to API data to my end users. Maybe I have like a different endpoint which is just for like the website and things like that. Okay, so that's kind of crash course intro to GraphQL and Sql Alchemy. Are there any questions on this before I continue?
Can you show the demo again? Like what happens when you do hello world?
Sorry, what happens when I do a
hello? You just created the backend for the hello world that
Yep.
will give you something back.
Yep.
How does the front end look? You just go on, find a web page, connect to the app you just exposed, and say /GraphQL and then hello world, or
right. So what I'm in right now is this like interactive GraphQL editor.
Okay, so I see the local host. So you connected to the app at localhost 5000.
Yep.
And GraphQL, this is the application you exposed. And what's the query? The query is whatever you're writing out there.
Exactly. This is my query down here. So this is the code. It's like if you were implementing your web app, say your front end application, and it needed to get the hello world information, for example, for whatever all the website was going to do is just going to print hello world out. Then in the front end code, you would include this query and like hit the GraphQL API with that query and get back the data you need. So the idea is that in say your JavaScript front end, you'll be writing queries. You'll use a GraphQL client and like write this syntax to say like that's the data I want to get from the back end. So this is like the language they speak to each other.
But the graph / when you say localhost /GraphQL, you get this nice interface, correct?
Yeah, this is for like for development and for like interactivity.
Okay, and this is what you exposed at the end there, /GraphQL.
Yep, exactly.
Okay, thank you.
Sam, I think I might have spaced out a little there, but I just didn't really understand where the OSO part comes in. I understand.
I'll get to that in a second.
Oh, okay.
So far there's been no OSO.
Oh, because I
There's
saw
just a
you
lot
used
of
it
a lot
there.
of things I'm introducing at once. I don't want to go all in one go.
So I didn't space out. Okay, thanks.
Does schema here have similar meaning here, like as a SQL database schema? Cool, yeah. Cheng, thanks for answering. Yes, exactly. It's basically the so we can see it actually. We can see it happening here. So okay, so here I'm defining the there's kind of like there's I have two different schemas going on here, right? Because I have the GraphQL schema here, and I have my SQL Alchemy one, right? So remember, SQL Alchemy, I had my expense model, which is defining what the data model is going to look like in the database. In GraphQL, I'm describing the interface that I'm going to expose to users in this like endpoint, and so just thinking about like the hello world one for now, because I actually have this app printing out the schema. We should be able to see it. This is what the GraphQL type schema actually would have looked like. So for example, here's my query type. Here are the different fields I can potentially query, and here you can see my hello world, which returns a string. So this is the data format that that the GraphQL API exposes. Now, where this is going to get a little bit confusing is I want to expose the same data models from my backend in my GraphQL API, and so this is where I'm using the Graphene SQL Alchemy piece. And so you see I have a expense class, and I have this like in a subclass thing, which is the method thing, which is referring to the expenses model. And so this is where I'm using the Graphene SQL Alchemy piece, which will basically say in the GraphQL API, expose the same model as is in SQL Alchemy that's in the backend. I don't need to repeat all the same stuff I had here. I don't need to say expense has an ID and an amount and a created by. It's just pulling that from the SQL Alchemy model. And so when I look at the schema that's printed out, wherever expense is sitting, here it is. Expense is up here, and you can see the schema contains all the. I'm going to make this bigger. The schema contains all the fields. The GraphQL schema contains all the fields that we defined in the SQL Alchemy database schema. And you should be able to explore this interactively as well. If I go in here, I can see an expense. An expense returns an expense connection, which has expense edges, and finally I get to my expense type. So yeah, this is now all like known and populated in the front end. Okay. And how do you test your models and your GraphQL API endpoints? That is beyond my understanding of how people use these things in production, I'm afraid. Yeah, I think in this case by sort of making this like one-to-one correspondence, it's kind of there's less things you need to keep like in sync, but in theory it can be challenging to keep the like backend code in sync with the GraphQL code. Okay, so what I was just showing there is I'm going to come back to here. Okay, so we spoke about the green piece Graphene, we spoke about the blue piece SQL Alchemy, and how I could add more functionality inside my app. It doesn't all need to be through SQL Alchemy. So where OSO fits in is in this authorization piece, sitting inside the business logic layer. And what we want from authorization here is to say, how, like, what data is this, is the user allowed to see, and like how do I enforce like they can see a certain piece of data. So if I actually go back to the GraphQL one, for example, if I go and try and read, I'm going to go and look up let's say the SQL Alchemy organization, which I'm not a member of, and maybe I'm going to go get the members with roles, and I'm going to go, so for every member, I'm going to go and get their login name, and I also want to know what role do they have in the organization. And I still need pagination. I always forget pagination. So, okay, so you can see I'm querying the GitHub API, and I'm asking for all of the members of the SQL Alchemy organization and what roles they have in the organization. In this case, GitHub is happy to return to me the members of the org. That's public knowledge, apparently. So I think this is Mike himself. But it's not telling me the roles. And in this case, it decided that instead of returning an error and saying I'm not allowed to see this, it's decided just to hide it from view. And this is pretty common, right? Like generally, if if I was to instead of asking for members, I was asking for repositories, they might have private repositories that it's just going to hide from my view. So there's kind of like some amount of like data filtering requirements going on here. And that's basically where OSO fits in, is around deciding who has access to what data in your application. So OSO itself it's an open source authorization system. The core of it is just a library, which allows you to make these authorization decisions in your app and do things like filtering data. It's available across multiple languages. So in Python, though, for example, it's as simple as pip install OSO. We also support Node, Go, Ruby, Rust, and Java. Fortunately, Java doesn't have a nice one-liner, so it doesn't get shown here. It actually comes with a bunch of batteries included stuff for things like defining roles in your app, for deciding who can see what inside like a UI, and just generally like having best practices for authorization like built in as things we include and have like well documented. But I won't be going too much into that stuff today. And kind of the final piece, which is like how do you actually configure it to decide who can do what, is through the policy language. So it's a declarative language called Polar that we wrote specifically for authorization. And it kind of looks something like this. So this rule up the top here is saying we say that a user is allowed to read an organization if the user is in the org.members. And this is declarative, so I'm kind of like declaring this to be true. Like if this condition holds, then they are allowed to do this. There's a few other kind of pieces in here which I'll talk about in depth in a bit. The application part of this is you use the OSO library, you like create an instance, you load in your policy file, so you imagine I load this into my OSO, and then I can just call it with isAllowed, and I just pass straight in my, say, Python data, my user object, my organization data, whatever it is, just goes kind of straight into the isAllowed query, and it will just return a true or false, like is this true or not. Okay, so in the context of my GraphQL app, I basically want to decide what expenses users can see in the app. So coming back to my application, currently, so I'm going to leave my email slot up here, but I'm also going to say I want to get back all expenses, and there's a lot of them. Let's look at the expense description, and let's look at the amount, and let's see who created this expense. And I'm going to get back a bunch of data here, right? So here's all the data it's queried for. I have various expenses like a pencil that cost 10 unspecified amount and was created by Alice. I've got some blue ink that was purchased by Bob. I had a new desk purchased by Alice, and so on. So this is like the entirety of my data returned right here. I can't help but see these chat comments around the bear paws. I had the same thought. They are the wrong way up, I know. Okay, so I have like all my expenses data. This seems like a little bit too permissive. This is my company expense management. Maybe as a user I shouldn't see that Jim spent a bunch of money on a chair. That's like I'm not allowed. So authorization in this context would be, I want to limit or restrict like what information, what expenses, say, a user can actually see in the app. Again, imagining that this would be the data that would be returned to my front-end application. So maybe I have a dashboard expense management application, and it's hitting this GraphQL API, getting back this data and displaying it to a user. So instead of through this interface, right, this might be displayed to a user. Okay, so I actually already have OSO integrated into this application, and it's using. I probably like skimmed over it earlier and pretended it wasn't there. So we actually have a specific Sql Alchemy integration for OSO, which allows you to like hook straight into that database layer. So here actually when I'm instantiating the database, I'm doing it using the OSO functionality, which is gonna effectively inject itself into queries that are made. And you can see I'm kind of telling it how to resolve who the current user is of like a particular request. And my API is all read right now, so that's the rules we're gonna be checking for. Yeah, okay. And the question I see in the chat around is it like deny or allow by default? I have this little rule up here so that I can actually show you data. This is effectively an allow everything rule right now. So this, rules typically by convention take in an actor, an action, and a resource. And by doing an underscore or just like adding no conditions, I'm saying this is like just unconditionally true. So this is now just true for all inputs. Everybody is allowed to do every action to every resource. If I completely delete that rule, so now all my rules are just commented out and I have nothing, by default I won't be allowed to see anything. And you see the effect of this immediately, right? So with the OSO authorization system in, authorizing those SQL requests, I can't see any data. And the effect of this on the API is just like there are no expenses to be seen. This isn't necessarily an error, this is just correct behavior. Like, Alice, you're not allowed to see any expenses. Okay, so, and then the idea is you can configure OSO to effectively express what authorization you need in your application. So I've got a few examples here I can walk through.
What if I wanted an error to be said, like you're trying to access something you're not allowed instead of not showing it?
Yeah, so you would probably want to. You
Is
wouldn't.
it something handled by also? That's the question, or is it something handled by GraphQL or something else?
Yeah, so the intersection of GraphQL and authorization is an interesting one. Yeah, so okay, so typically in a regular app, in a non-GraphQL app, you would normally make an authorization decision and maybe return an error, return like a 403 or something, saying this is not authorized. GraphQL doesn't really expect that to happen. You could, so that's why in the GitHub example I was showing, the sort of GraphQL convention is just to like hide things that you aren't allowed to see. So like null them out. Even if I'm allowed to, if there's a specific piece of data I'm not allowed to see, the GraphQL convention is like hide it. You would maybe do at, if this made sense, if there was like an entire field you weren't allowed to access, like you're never allowed to see members with role, then you maybe would return that as an error, and you'd have to kind of like implement that maybe in your resolver. So what I could do, for example, in here, maybe in here I would have something like g.oso.isAllowed, g.current_user. Is the current user allowed to read, I don't know, hello world? And like if this is not true, if this is true, then return it. Else I'm gonna like raise an exception or something. I think this would make sense if there was really a piece of like a special piece of authorization that was like specific to something you're resolving. You could add it into the business logic piece here. But I think in the case of, I have a data API and I kind of, my expectation is that you just can't see the things you're not allowed to see, not that they error, then it's kind of nice that you get it done, that it's just happening kind of like transparently at the Sql Alchemy level. So, okay, so for example, what I might want to say is that users are allowed to see their own expenses, and so this takes the following format. Oops. I write my allow rule. I say the input is a user, and this like colon syntax here, which sort of looks something like Python type checks, is very similar. This is checking that the input that we pass it is in fact a user type, and so you might have like different user types, like maybe you have a machine identity, or like you have a super user type or an admin or something like that, that you could maybe configure these differently. We said the action was a read, and the resource is an expense. And again, I'm going to make sure that this type is actually an expense. This is aligning with the Sql Alchemy types. And I just want my simple check to be, I'm going to use the created by fields is equal to user. So where are these coming from? Coming from my Sql Alchemy models. So expense has a created by field, it's a relationship with the user. I am just referencing those exact fields in my policy. So is the expense created by the user? I should be able to come back here and run this again. Okay, we have some progress. So I can now see the pencil and the desk, which I think were written by Alice, but I bizarrely here, right, I'm getting nulls for the created by fields. And this is because we're actually resolving authorization like all the way down the GraphQL API. So yes, you're allowed to see the expenses you created, but I don't know what users you're allowed to see. And this is like something that's particularly tricky with GraphQL is that the queries can get sort of kind of nuts, like because you are like navigating this graph and you can kind of go all nested, right? So where I looked up the created by fields email, I could go further and be like, I want to see all the projects of the person that created by, and for every project I want to see all the expenses of that project. And well, maybe if I'm not careful, then the user is allowed to see this expense. They're allowed to see the owner of it. They're allowed to see the project of it. Maybe they can see the expenses of that project, but maybe they like somehow manage to bypass authorization by doing that. So GraphQL can actually be pretty tricky to get authorization right because of that like flexibility. So basically, what we're seeing here is going on is that we're applying authorization at like every level. So is the user allowed to see? Are they allowed to see themselves? Right now they're not. I'm going to add this rule at the bottom, which just says users can read all users. We'll allow users to see each other. Great. Now I run this again, I get the proper data back. And so that's kind of the core of it, right? Is we're basically able to write simple policies to configure who can see on our application. You can see that it's been enforced at the GraphQL layer, but this exact same policy I can use in my regular endpoints. Like if I just have a REST API as well that returns expenses, if I have some other custom methods for it for doing other things, it's all going to be based off the same policy. It'll all be going through the same like OSO library to enforce that authorization, which is kind of the vision of this idea of authorization being this kind of piece of the business logic layer. The kind of other thing that we kind of believe at OSO is this idea that like authorization kind of has to be in the app. It does kind of have to be in that business logic layer, but ideally it will be a separate piece. Like I think for a lot of people, this blue and yellow is more like kind of mixed together in some shade, gradient kind of thing, where it's like, is it authorization or business logic? But the kind of this benefit of being able to express things in your like policy is that your authorization logic stays in the policy file, and your application, as we saw here, just doesn't need to worry about it, right? Like my schema file has no authorization in it. It doesn't need to worry about it. It's a concern somewhere else. Is there a way for a superadmin to change the policy via a query? Okay, so that's a great question. So we like our current view is like you should treat your authorization logic like application code. So in particular, it's sitting in my application directory next to my Python files. I deploy it with my Python files. I manage it in the same way. It's part of my development experience. It's this is great for a number of reasons, right? Like I can run this Python project locally, and it has the policy there. It's not like stored somewhere else. I can read it. I can see it. I can you have like a built-in debugger and REPL. You can like interact with it. The if pieces of a policy which should be dynamic. So in particular, right, like the query, the policy I wrote here is very, very dynamic. Like users can read expenses they created. This is using the fields in the database. So anything that like should be changing, updated part of the policy, anything that's dynamic should be stored in the database as a regular part of your application data. And yeah, but we have sort of right now it's not possible. There's no interface for like live updating policies, but it's something we've actually had a few people asking about, and we'll be spending some time on soon. There's actually one other piece of this which I think is really good fun to see. So we also have this SQL endpoint on our local host, which is printing out the SQL that's run as part of this. Like the last API request that was made prints out the SQL that's run. So for example, you can see the fetching the user that happened up here. The really cool thing is the policy that I just wrote this expense must be created by the user. It's written in OSO in the Polar policy language, but it's actually being enforced at the SQL level. So we have like an adapter that will take the policy constraints and convert them into SQL filters. And so you can see the query that's actually made to fetch all these expenses is, this is basically my policy here. The expenses created by ID is equal to 1 because that's the ID of Alice, and it's like as simple as that. So it's like incredibly efficient as well. Okay, so those are the main things I wanted to talk about. There are a bunch of links if you want to find out more. I really only just scratched the surface of OSO. There's some other pieces. The core of this is all written in Rust. So we've written up a bunch of how that is. So the core of this is written in Rust and kind of like exposed through this interface in things like Python. I'm going to copy and paste these into the chat if you want to click on them instead of trying to type
Sam,
them.
what's the right way to test what you're exposing, or is there any way you can work this into your unit tests or anything like that? Because you are advocating that it's part of the application code and so on. It's sitting right there with everything else. So.
Oh, for the policy specifically?
Yeah. Just because I would assume that if you have a fairly complex data structure and there's a risk of over time what you're exposing with what seems to be, eventually will come out to be a fairly complex policy file.
Yeah. So like there's kind of a couple of answers to that. So probably still the most reliable way would be to have like good test data and checking that things are allowed or not, and the things you expect to be allowed. You can. So some of the stuff I have commented out here is just to show that you can kind of like write multiple rules. So I could maybe refactor this rule from like allow if this condition into like a combination of things, which maybe has like a created like sub rule that it calls into. And you can kind of like query individual pieces of your policy. So you could maybe ask like more specific questions as part of a test suite. Like, I want to just unit test that the created by rule, the created rule works in isolation. I'll just query that piece and test the inputs and outputs of that. You can actually write like inline policy queries with like this syntax question mark equals, like maybe you do something like this, like maybe you create a user, something like this, like can this user read like an expense, and maybe something like, so maybe you like create some data and do like a little inline query to check like can user ID 1 read the expense created by user ID 1 or something like that. So you can write like inline queries to check various pieces of the policy. So that's kind of what you can do today, but this is an area where we are probably in the near future going to be investing more time to allow you to sort of more directly like unit test the answers you get back from a policy, because the one kind of output you get from this, and the one that's used for like doing the filtering, for example, is you kind of pass in something representing like the expenses query set, like the expenses model, and you kind of ask it like, what expenses can this user see, and it returns you like a list of constraints. So one of the things we're like investigating doing in the kind of near future would be allowing you to write tests over those like constraints you get back. So you could write tests that say things like, there must be a condition on this user reading an expense. Like, check that there's at least one condition on this allow query. Maybe it's check that the condition includes a role check, for example, if you have a role-based system. And so that's like one of the things we're going to do in like the near future is allow you to sort of interrogate specifically the response that you get back that has the expected components.
And if you put instead of just accessing a field on any of your SQL Alchemy models, if you had like a method or a property that you added to that, can you include that in the query?
Yes, it's sort of the data filtering part of this is somewhat recent, so it doesn't fully support you being able to kind of mix and match the two at the same time. But like you can't just use you can reference like Python attributes and Python methods inside the policy. So I could say something like user.email and that's not the Python one, ends with foo.com, for example. Like allow user to read expense still.
Well, let's say, for example, you had user first name and user last name, but you had a method that was like user full name.
Yep.
Would you be able to add?
Absolutely, yeah. So this would work, for example, where I'm using the Python built-in string method, like email ends with, and right. So yeah, this worked now for everything. I can now see all the expenses because I said a user can read an expense if their email ends with foo.com, and no further questions. But you can't currently. I wouldn't be able to do that on expense currently because that's been done like on the filtering on Sql Alchemy side of things.
So Sam, I think I suspect something is happening here. Eric is asking a question for a reason. He actually might need something like this. So please explain also a little bit what it can and can't do, and give it in context of Django or Flask or something like this. Like
yeah, absolutely. I mean, my systems are using not using SQL Alchemy, but they're using Django, and I know that I'm just looking now and I can see there's a Django Graphene Python module.
Yep.
But I don't know if also can then link into that.
Yeah, we also are you using GraphQL? Are you using the Graphene thing or just Django?
No, I've been following your tutorial, so.
So we also have a Django integration.
Okay.
So if I go into my
Eric, tell him what you're doing. Maybe it will give him some hints.
I'm watching the presentation, Jacob.
I know you're not. You have something in mind. I know it.
No, I
He has something in mind.
Yeah, I'm not really sure, but I mean, it looks so familiar that I've worked with REST API, Django REST, that kind of stuff. So I'm just trying to see where this fits in.
Yeah, so Django, we have someone actually who's been working a lot with doing this in the Django REST framework, which is a similarly really good fit because what the Django REST framework does is give you that sort of very structured, API to data model piece. Yep. And so they actually wrote this. Here's an example, and you can find it on the inside our GitHub organization, I think, as well. If not, there's a link to the Slack. You should come join that and chat about it. Okay. But this is very nice because it just adds in kind of a very similar way. It just adds OSO as a little filter, and does the exact same thing. It just calls the OSO authorized method as like a generic filter on the inside the Django REST framework filter, and then everything else kind of looks the same. So they've been working on some pretty complex policies, doing role-based and relational kind of policies, which for some reason isn't loading because VS Code's loading Python extensions. But yes, all the same kind of stuff applies in Django. Here we go. Yeah, so this kind of thing's happening here.
So Sam, let me expand it towards some other users. We have many beginners who lost you at Django. So now, I'm not kidding. They lost you at Django. Can you explain in simpler words, like they might know Flask, and even this sometimes is complicated for them. But they will reach a point that might want to use also. So tell them like the simplest thing that it can do. Like, for example, can it create a user database for me or access database to an application that I write without using the word REST?
Sure. So, okay, so I've been talking about, a lot here around, building the web application, and maybe that's the back end that the front end website is talking to. And the pieces we spoke about today was like, there's Flask, which is the providing the web framework thing, so the back end that can process requests and return responses back to the clients. There's the GraphQL piece, which has its API. There's like the Sql Alchemy, which is the database. You can think of Django as basically covering all of that. So Django is basically entire web application framework in one. So in particular, it gives you, let me go load up this. What's the chances this is actually gonna work? Maybe.
Yeah.
All right, let's open this code. Okay, so here I have a GitHub app built with Django, and for example, you can see I have in the side here everything mentioning models. So much like I was just showing with Sql Alchemy, Django has a Python object-oriented way of expressing your data models. So in here I define my repository, it has a name, an organization, things like that. But Django includes everything. So Django also has a way of writing views, which is where I'm kind of talking about some of that like business logic of if a user requests to see a certain piece of data, what's like the data I want to respond, and also things like templates. I don't know why this is going so slow. Too many VS Codes open. So here I have like the application code written to decide how to respond to a user who visits like the repositories page. And so I should be able to, oh, this is not looking great, but I think I can log in as Alice. I don't know what the login for this would be. It's probably in the README somewhere. Anyway, you can see it, right? So this is all being served by Django. So Django is actually rendering the front end as well. It's using some of these like HTML templates that I've got here to determine what front end code to display. So it renders the HTML to be displayed. It's handling the request that comes in, the data models, like basically the entire thing you need for building an app. And where it also fits into that is much like I've been talking about today is, for example, if I want to say what repositories can this user see, it'll filter them down. If is this user allowed to see a particular page, you can make those yes/no decisions by writing the policy logic.
So if I say the sentence without also, it would be very complicated to handle using to handle user access. Will it be a correct statement?
Yep.
Okay, so also simplifies many things that those web frameworks do not provide with regard to user access.
Yeah, so typically, managing access, permissions, things like that, it kind of depends on having some, like the web framework normally has like some native support for it, or there are additional modules you can use. So for example, Django does have one called Django Guardian, which allows you to do some permission stuff and so on. So like every framework has its own way of like approaching these. What also kind of gives you is a consistent way to do that across not just like any framework, but any language. And it actually goes quite a bit further than a lot of these. It gives you, we've really tried to make it as like easy to use out of the box as possible. So in particular, like on our docs page, docs.osohq.com, we have like a ton of guides walking you through like what are roles, how should you even think about roles, how do you add roles to your application with Sql Alchemy, or just generally kind of like talking you through like what you need to focus on in authorization, like where you should be doing it, and generally just trying to like educate you on where those things can go. And then basically just giving you a library makes it easy to implement those patterns that we teach you about.
So if a beginner wants to approach and ever needs to write some sort of user access code, then they learn also once, and it applies to many systems and many languages, and they don't have to repeat and read it learn many libraries.
Yeah,
correct?
Exactly.
Thank you.
Yeah, so speaking of the many languages, so I think you mentioned something about Java. I know this is a Python era, but I have a particular interest in Java. So how does it look like? I know like in Python you use the Sql Alchemy like like in Java world, like how are those things tied together? Maybe don't cover too much on that one, but kind of I want to kind of get like a very broad view of how that works in that world.
Yeah, we basically have the language libraries themselves, which have like the basic interface, allow you to write policy and do authorization over your like application data objects. And then we have in specific languages, we have like additional framework integrations. So like you can use like the base Python library by itself to do authorization, but if you want to do like more advanced stuff like the data filtering with Sql Alchemy, use the Sql Alchemy integration specifically. Um, so like for Python, we have Flask, Django, and Sql Alchemy integrations, which like add additional stuff on top of the base library. But the base library itself is still like incredibly powerful. You can come in here and see like different examples of various like access control patterns, like how to write things like attribute based or role based stuff. You can still do all of this through the core Python library or the core Java library or the core Ruby library or whatever. But there are just ways that we can make it both more convenient and more powerful when we do that like extra deeper integration with a framework.
All right.
Yeah.
Yeah, thank you.
Now I have a trick question and a nice question. Which one do you want?
Trick.
The trick question.
Is this trick or treat? Trick.
I'll ask a nice question first. What is something that also can do that most authorization system cannot do? Can you show us one thing that's like just one small thing to remember?
Yeah, so the really cool thing about I think the really cool thing about the system is that it allows you to write policy in this declarative style. And so the kind of the really nice thing about this, like there's not a whole lot going on here, right? I have two allow rules. One says user can read and expense, and one says any user can read any other user data. Like, okay. But the important thing is, right, I wrote these two allow rules, and I don't need to tell OSO like how to, which order to execute these rules. Like, as these get like multiple rules, and I break them up into other pieces, and I extract the logic out. You don't need to tell it like what to do. You just tell it what you expect to be true. And so like the policy engine here is the one that's going to evaluate these conditions. So whereas normally in an app you might end up with like, oh, if user.is admin, then like else if do something, then like if user.roles includes, I don't know, like blah, then and if the project like is public, then maybe I'm going to go and do something. Like you avoid this kind of like horrible nested logic. You should write it in the policy, but it's still as simple as just writing it over your data, over your fields, over your attributes, stuff like that.
Nice. So it's much simplifies much thing, and it says its own solver, like a stat solver or something inside.
It's a Prolog variant, so it's
okay.
a backtracking algorithm basically.
Okay. Now the trick question. What else can also do except from authorization systems? Like, can it apply to something else?
That is not a trick question. That's an amazing question. I'm going to come back to that one in a second because I see Astrokar has a question which is less ridiculous. You can do negations within the allow. So I can just say not. It's kind of simple as that. This would be a negation. Like a user can read an expense if the user doesn't end with foo.com. In the case where you maybe build up like multiple of these rules, maybe you have like a deny rule or something, and you say like allow if not deny. Typically these get broken up into like smaller and smaller rules. Yeah, Graham is ahead of me on linking. That's great. I need to go find that. So yes, you can do negation with not basically. So I was going to go find the blog because we've had some people on the team who are rather creative and ask exactly that question. Like, what else can we do with this language? Like, it is a logic-based language. You can, in theory, do anything with it. So one hackathon, they did a text-based adventure game with the language Polar.
Whoa!
Which you can go and play and download, or like run it online. You can see, you write commands like go to the iron gate or look envelope, and the policy is one that's like evaluating what happens. And then there's a blog post we wrote up on it. And this is really convenient. Thanks, Graham. Similarly, this past December, Steve did the Advent of Code challenges in Polar. So Advent of Code, they run these like daily coding challenges every December, and he had a go at doing them in Polar. So this is kind of like, this is what some of the sort of more complex Polar gets to that is sort of rare to ever encounter in the context of authorization, but it's kind of nice to know that you can really write whatever logic you want. Like, it is powerful enough to, like, we've kept the language as lean as possible because we do rely on Python for methods and stuff like that, but you can write logic-based programming in here, and it's kind of out of scope of this for me to walk through what's going on here. But for example, this computes the sum of a list. It's saying that an empty list, the sum is equal to 0, whereas for a list of elements, the sum is computed kind of recursively by adding on the answer to the previous one, things like that. I see a question about how a conflict's handled, e.g. user can read X, user can't read X. So that kind of brings me back to this one. So if you have a policy where you maybe have something like an allow list and a deny list, and allow unless deny, or deny unless allow, if something like that, you represent that through writing the rules. So maybe we have you can basically choose here what you can basically combine your rules here differently. So maybe I have like a maybe I call this one like a like resource allow or something, and I'll say allow if resource allow user read expense, and not, maybe it's like resource deny. So basically it's effectively up to you on the kind of logic you want to implement. Like if you have things like conflicts, to decide how you want to write that logic. Like this would say that there must be an allow and not a deny, but you could also maybe say either an allow or there's not a deny. So like if there is no rule, then it's just allow by default or something like that.
So
Okay.
Eric, what do you use for your clinical trial systems? Like
What do
for
I-
yeah,
do I
Eric
use?
writes clinical trial collection, data collection
Yeah.
systems. This is why I was like thinking, what do you use for data authorization? Like the user allows access to this and not to that.
Well, I have my framework sort of extends out the Django admin, which has its own built-in authentication. So I can control, create, add, view only, all that kind of stuff, delete. I can control all that, control what they can look at, what they can't look at. Yeah.
So can this simplify this for him?
I don't know. I mean, it's interesting. So I want to. I mean, at first I thought, Sammy, you were just talking about something that helps with GraphQL, and it allows you to put authentication in there. But now I realize that this is actually much broader. So that was just an example application of it.
Yes. Yep.
So yeah. So I just want. I'm gonna look more into it. It looks very interesting. I'm looking on your website as well. So
Yeah.
although I being at a Python group and talking about a language that can do almost anything in any way is a little bit against our rules. There's only one way to do it, I thought.
Not JavaScript.
Exactly.
I guess. Well.
So all
Yeah.
I would say to that is are there like do it this way, don't do it that way, or or you're really just leaving it to those of us who look at it and see what we can do with it.
Yeah, I mean that's where I'm just gonna stop for now. Actually, that's where we're kind of more and more moving towards providing a lot of that stuff, like batteries included, like the Python standard library style thing, because we sort of found that things like role-based access, there's like a bunch of different ways to implement it, but like most people's need for roles all follows a very, very, very similar pattern.
Yeah.
And it turns out if you just give people that pattern and ask them to apply it, they'll probably be pretty happy, and then they'll have a system that works for them for now and for the future and things like that. So we're definitely moving more in that direction where it's there's actually a talk I gave earlier today on exactly that, SQL Alchemy and roles, where we basically showed that like you use our built-in roles, you don't really need to add you add like 2 lines of code, and you don't have like a reasonably good like opinionated authorization system. Graham with the very helpful links in the chat here. Graham's my co-founder and CEO. That's why he's been so helpful.
Okay. Yeah, because for the data that I work with, it's it's healthcare data, so it's very sensitive, and so I found that the way to do it right is to define roles, and you can test those roles really well. You might want to group roles within roles or something like that, but at some point it's not going to change much from there, as long as you can. Yeah,
that's exactly right. So this kind of gives you a out of the box way to do the roles with the policy to write it. But like the nice thing here is the thing that can often be challenging with roles and that can get people into very difficult situations is when they don't have enough flexibility. So the only way they can address a certain problem is to, for example, like add a new role. It's like, well, this it's like this piece of data, is set to private, and I don't really want this role to be able to see it, so I'm going to create a new role that can just see those data in a different, and like things like that. And like, roles start kind of like proliferating. You end up like 50 roles and no one understands what role they're supposed to have. So in the talk I was giving earlier, the kind of like my best practice for role is like have as few as possible and have them be related to like an intuitive concept of what the user is expecting to be able to do in the app.
Do you have the ability to decorate, for example, a field within a model that that only this role is ever going to touch that field? For example, I do randomized control trials, and the randomization data cannot get out to anybody but a statistician. So it would be very convenient just to decorate that field with a role, and nobody else can touch it, for example. I don't know. And somehow that ties into a role that's defined just as a precaution, that you can't make a mistake to accidentally expose that data.
We don't currently have anything like that, like to add a decorator. That'd be something that you'd still want to define like in the policy code itself.
Okay.
Although, so we don't have anything built in for that, but because all of this is just written over your Python data, you can adding a decorator to fields, as long as it's accessible in the policy in some form, you could use it. So you could write a generic like allow rule, which basically says, the user allowed to see this as long as the field doesn't have an attribute restricted or randomized or protected or whatever it is. And so like if you annotate your Python data with that field, like you can very, very easily just use it in the policy.
You can write your own decorator that just adds this field to the function or add something to this class.
Right,
and
exactly.
therefore you can decorate it, and then you just so you can write the decorator that does this for you. But if you guys have it out of the box as a service, then you actually solve this problem.
Yeah, no, and I love it. I think it's a great example when we're all about more of those kind of patterns that we can just like include in the library and make easy out of the box.
This was the reason I told you he has something in mind. I know what he's doing.
I would very highly recommend if you joining our Slack and coming and talking to us about this. And there are other people in there using Django who are, I think, doing similar stuff. Like we have this example app that someone built based on a previous role they did, where it was like a caseworker management app, which I think has like similar kind of areas, because you have like caseworkers have some files and you have like clients have some files, and there's like overlap of those. And that's like very, very heavily role based, because it's like, are you assigned to this caseload and this client? If so, you're allowed to see, the documents inside that one. And and that's also heavily using the Django admin interface as a kind of like as like the admin interface, like the customization interface. Like if you want to assign a role to someone, you can just do it through the Django admin interface.
Yeah.
Because you're just modifying Django data. Yeah.
Good.
And yeah, so like I think the nice thing is the sort of using, say, the built-in roles thing we have. You can, like the simplest usage is to say, a particular role, like admin is allowed to read a expense, say, and like that, that is just the rule without any conditions. But you can, if you need to be, you can be more nuanced. So you can say like, well, okay, but maybe a member is only allowed to read a repository if the repository is public. Like you're still doing role-based access. Like your roles are still written around that concept of a role, but you can just be as fine-grained as you need to, like on that aspect, instead of having to, generally that kind of that logic gets pushed into the application.
Sorry if I missed this bit, but how do you configure roles for users? Is that like something you have to do in your app, or?
So when you mean configure for users, you mean like assign them to a role, that kind of thing?
Yeah, yeah.
So let me. I've got here's my demo from earlier. So here's how I define the roles in, say, Sql Alchemy. We have this helper that creates a mixin, and you add your mixin to your Sql Alchemy model. And so yeah, so in this case, we're now going to have like a new model which links users and organizations and says they can have a role from this list. Then in the routes, we do have some. I mean, at that point, this is just a straightforward SQL Alchemy model. Like you can insert in the regular way, but we do also add a few helper methods. So like add user role here. So in this example, and again, this is on like in our docs, we have a guide of how we built this one and stuff like that. But maybe there's like a new roles endpoint. First, you want to authorize that the user is allowed to create this role, and then we have the helper methods to like either add them or reassign them if they already have a particular role, things like that.
Gotcha.
So yeah, basically there are helper methods to do it. I was just reading. Yeah, Gabe's confusion over separation of concerns. Yeah, the separation of concerns was like a very important aspect to us, a piece that we're particularly keen about. We actually wrote a little bit of our design principles up, which indeed is about separation of concerns but not data. Like the idea is, like authorization is this really hard area in general to like make entirely abstracted from application, because everything I've spoken about, right? Like a user can see an expense if they're the expense owner, or a repository, if you're in the organization. Like you can't imagine that data being anywhere else but in the application. I think the app would find it hard to function if it didn't know what organization a repository is in, or what expense who an expense belonged to. So there's this delicate balance between separating out the logic but allowing the data to stay in the app, and that's kind of like our core underlying principle when we started building everything.